Today, we're going to dive into a breakthrough that could seriously change how we make the medicines we all rely on. And it's a story that starts at a level you can't even see, with the tiny crystals that are at the heart of every single pill.
But first, I want you to just take in this number, $50 billion. That is how much the pharmaceutical industry loses every year. Not on research, not on marketing, but just from inefficient manufacturing. That is a staggering amount of waste, and it points to a huge problem that's been hiding in plain sight.
So where is all that money going? I mean, how do you get to a number that big? To understand that, we need to look at the very first, most fundamental step in making a pill, a process called crystallization. Okay, so crystallization is absolutely essential. It's how drug makers take the raw active ingredient, what they call the API, and purify it, turning it into a stable, solid crystal. This is literally the foundation of the medicine. But here's the kicker. The way it's been done for decades is, well, it's incredibly clunky, expensive, and just plain slow.
So what exactly is so wrong with the old way? I mean, it works, right? Well, kinda. But it turns out the entire process is held back by a few core, interconnected flaws that have been costing the industry a fortune for years. And this diagram shows you exactly what we mean by clunky. This is the old-school method. You start with a crude ingredient, and you run it through this cycle of recrystallization, filtering, cleaning, and you don't just do it once. Oh no. Sometimes you have to do it up to 7 times just to get it pure enough. It's like a factory line that has to constantly stop, start, and do the same thing over and over again.
So this messy process leads to 3 fundamental problems. First, purity. All those repeated steps take forever and cost a ton of money. Second, performance. The final crystal you get is big and blocky, which means it actually struggles to dissolve in your body. That limits how effective the drug can be. And third, the process itself. It's all based on trial and error. It's more of an art than a science, which makes it super inefficient and almost impossible to scale up properly.
This got some researchers thinking, wait a second, what if we're looking at this all wrong? What if the problem isn't just fixing a clunky assembly line? What if we could build a fundamentally better crystal right from the start?
And that brings us to the mesocrystal. Think of it this way. The old method gives you one big clunky brick. A mesocrystal, on the other hand, is like building the same thing out of thousands of tiny, perfectly formed Legos. It's a smartly designed bundle of nanocrystals engineered from the get-go for amazing purity and performance.
And you can really see the difference here. On the right, that's the old-school crystal. Big, smooth, and kind of boring. But on the left, wow, that's the new mesocrystal, made of countless little particles. And that complex structure is the secret sauce. It gives it about 100 times more surface area. Why does that matter? Well, it's the key to helping the drug dissolve quickly and get to work inside your body. And of course, this new type of crystal comes from a whole new process. So remember that complicated, repetitive mess from before? Well, this new non-classical method takes all of that and condenses it into a single, elegant, continuous process. You go from the crude ingredient to a high-performance mesocrystal all in one shot. And the results are, well, they're just staggering. In a proof of concept using the drug curcumin, this new method took a starting material that was only 78% pure and refined it to over 99.8% purity, not in 7 steps, in 1.
But here's the thing. To build these revolutionary new crystals perfectly every single time, you can't use the old equipment. You need a revolutionary new kind of factory, one that runs on data and precision, not guesswork.
And this is the blueprint for that factory. This system is basically the brain and the central nervous system for this whole operation. It's designed from the ground up to be a fully digital, continuous manufacturing platform.
So how does this smart factory actually tick? Well, it uses sensors for real-time monitoring, so it's constantly watching itself to make sure everything is perfect. All that trial and error guesswork, gone, replaced with predictive models that know what's going to happen. It can run in this special superstat mode, which is basically a state of constant optimization for maximum output. And it connects the whole process together seamlessly, from start to finish. This is a huge shift from an old-world craft to a data-driven science.
So let's just tie this all back to those 3 original problems. The purity problem? Solved, thanks to single-step purification. The performance problem? Solved, thanks to those high surface area mesocrystals. And the process problem? Yep, solved by a smart, continuous, data-driven factory. It's not just a patch, it's a complete, integrated solution that tackles all 3 issues at once.
Now, this is way more than just a cool science experiment. This shift from a simple crystal to an engineered one has massive real-world implications for our health, for our economy, and even for the planet.
Think about a country like the UK, which invests over £30 billion a year in pharmaceutical R&D. By adopting advanced manufacturing like this, it has a massive opportunity to turn all that incredible research into global leadership in actually making the medicines of the future.
And the size of that opportunity is just huge. The global market for poorly soluble drugs, which is exactly the kind of medicine this technology is perfect for, is projected to be worth over $286 billion by 2032. Unlocking that market is going to require this exact kind of innovation. And this isn't just theory, it's already being applied to some really high-value medicines. The technology is being proven on drugs like curcumin, with a market that's set to hit £151 million, and simvastatin, a cholesterol drug that makes up nearly a third of the entire European market. So, when you put it all together, this isn't just one small improvement. It's a whole cascade of amazing benefits. It positions countries to be leaders in next-gen manufacturing. It's way more sustainable, using less energy and creating less waste. And maybe most importantly, it could lead to more affordable, more accessible, and more effective medicines for everyone, all through greener and more flexible supply chains.
You know, this entire revolution started just by rethinking the most basic building block of a pill. And that leaves us with a really powerful question. If we can so completely reinvent something as fundamental as the crystal, what other core ideas in medicine are just sitting there waiting to be redesigned from the ground up?